Hello everybody, I'm Theobrey and today I'm gonna show you a new tool which is deformation mesh tool, and in this tool you will be able to create chunks of matter or ores, I don't know, just like that, uh, by using a brush where you can uh, make it bigger or smaller brush sizes, as you can see here. And you can do whatever I want. You can place, you can remove too, or if I go with a bigger whole sphere, you can see that I'm erasing more over there. So of course what you can do here by looking at the little guide here, if you press uh, C, you will clear the chunk. So while I'm in the chunk, I press C and it clears out everything, and I can rebuild it back or modelize to whatever I want. And then once I'm happy with it, I just can press R, and it will save it. So as you can see here, you have changed save. So now if I exit and go back in play mode, we have exactly the same pattern that we've got because it has been loaded. If I do more, and I save and I exit and I come back, as you will see, you have the three more dots here. So here is an example and demo scene of what my tool can do. So you can use it, for example, in a game where you have mineral to pickups and or deposit. You want to mines. You can use this tool, and you can place how many you want. Uh, Obviously, you have to hide some because you obviously you will not display them every time, but you can like hide them where you are far away from the player, or you can do whatever you optimization you want. But the base technique is here. It's a voxel based technique, so it's called marching cubes. So as you can see here, it's a voxels, it's a grid with voxel points, and the mesh is automatically adjusting based on this algorithm. So there we go. So that's all for this part, and welcome back. So in this part we're going to go deeper into the tool. I will show you everything you need to know to implement it in your game. So the the tool is made of only those ports and some ports in C++, but the one you need is BP deformable base standalone. So as you can see, you have one here in the scene, one here, and another one there. So here's the 0, 0 of the chunk. So each blueprint will be a chunk that you can move around, but there is one rule that you do not have to rotate them. It's only displacement, and you don't need to rotate them because you can, as I shown you earlier, just model them and yeah, like move everything. You can do whatever you want with them, so you don't need to rotate them. Um, all right, so basically this BP deformable mesh has nothing in it. So in the blueprint, it's just that it derives from this C++ class, which does all the job. So it's only to retrieve information and activate I don't know, functions from your main character, for example, or from anywhere you want to access the values and the functions that will make the chunk work, the deformable chunk work. So For what you saw, for example, the sphere, and the way you place and stuff is all calculated in the first person character. Uh, so now for the customization part, you saw that you have different looks. So there is a few parameters that you can customize here. So I'm gonna show them. So as you can see, if I click on this blueprint here, there, you will see that there is a variable which is in data asset, and this data asset is uh, derived from deformation mesh data asset. So it's the way you can create them is by going to um, tool object or wherever you want to project. You do right click, you type data asset, and then you search for deformable mesh data asset, select, and then you name it what whatever you want. I don't know, tin, for example. And then in this data set, it will be empty. So uh, for in order to everything to work, you need to put the surface level at 0.5. Um, you need to put a surface material. So the surface material will be the material which is applied to the mesh part. You see there is two parts. There is rocks formation and then the actual mesh. So surface mesh will build the material which will be applied here. So for the purpose of this demo, I've used the triplanar mapping shader, but feel free to take mine and modify it the way you want, because it won't take UVs. It only takes triplanar mapping. So there we go. Then after that, you have to fill up the source surface mesh. So the meshes that you see above the main mesh, so those little rocks formation here, is the mesh that will be replicated everywhere. So it's, yeah, here. So as you can see, for the gold, I have this gold chunk. I have a surface mesh spawn probability, so it's to increase it's capped from 0 to 1, but the more you put and the more probability you will have to get those surface mesh here. So for example, for the gold, if I go to 0 and I save it and I go, there is no more internal meshes, you have only the surface. But if I go to like 1, you have full meshes, there is everywhere. So I go by dividing them, I put 0.5 and I think it's okay for me. I can check here if I want to my surface mesh to affect global illumination. I turn it off by default because it's very performance intensive because of nanites. Mostly because of the reflection. If you put too much reflection on your mesh, on your material, it will bounce everywhere and it will probably disturb your FPS. But you can disable nanite or lumen if you want, or you can disable surface mesh affect GI, and it will not calculate the lights. It will not contribute to global illumination. So it will in fact not much changing your look and gain huge amount of performance. So I recommend it going off for now, but maybe in the future when you're in Real 5 will be better handlings the global illumination, maybe you can turn it on back. So the grid size here is the definition of your voxel grid. Um, so for example here it's a grid of um, 20 by 20 by 50. So there is here, if I clear it, um, you can see here it's those little triangle. Yeah, here it's a point. So there is 20 by 20 by 15 of them. So it's the resolution. And you can change the definition too. Uh, Voxel size. So here is every point are spaced by 28 units, sorry. So don't go over those value because otherwise the calculation for the chunk will be, I think, a bit slower. I recommend you to put more little chunks like that and decrease the number of grid size and increase the definition. So here there is another check that I can like check or not, and if I use procedural generation I bypass totally the data that were saved before, so it's just using a regular Perlin noise to generate the mesh. So it's up to you, but if you want to use the data stored in the data set, you just check it, uncheck, and then you have the data you've saved previously. So there we go. Then finally you have the pre-generated scale noise. So it's when you check that, you can set the procedural noise scale. So if I go to like I don't know, 0.1 or 0.5, I don't know, but I recommend putting smaller values and I check procedural generation. You will see that you have a very high frequency pattern. So I recommend you to go like 0.05 for example. No, it's a bit too much. Again, 0.01. Yeah, now it's getting smaller, but yeah, it's procedural generation, it's Perlin noise in 3D. Uh, Maybe if I go like, yeah, those smaller value, and here you will see that you have Ks and stuff. So yeah, there we go. And then the final slot here is very important because it will define uh, how the dataset retrieve and which data the dataset retrieve to load back your chunk. So for example, if I call it gold chunk and I press play, it will search for the save slot named gold chunk and it will generate it. But if I change gold chunk and I put 01 after that here and I press, it said that the chunk load from dataset error no save data, so it's creating a new one. And for now there is no data, so he generates Perlin noise, just like that. But if I like clear and make, there we go, save again, and I go back, yeah, this save is okay. But if I delete 01 and I go back to the previous save and I press play, there is the previous one. So it's the way you can change the, you can select the save you want by changing the name here. So that's all for the customization. For the next part, I'm gonna talk you about how you can retrieve those functions from this procedural deformable mesh to your own first person character, for example, or everywhere in your game. So, see you. So welcome back. In this part I'm going to tell you how you can integrate all those blueprints in your actual game or in your actual game flow. So for them, in order for them to work, uh, everything happen here. For me, I put every logic, everything in the first personal character. So this one is just for accessing, as I said, the internal function and variable. So everything is going into the first person character. So first of all, what I do here is I register them as a activated chunk. Uh, this whole stuff just cycling through a loop with a timer. So every few seconds, every 5.5 seconds for exactly, it will check if I'm into a chunk. So it just take the bounding box of the mesh, the chunk, and take my position and check if I'm inside. Then if I'm inside, it's just add the is the blueprint as an activated one. So now I have the reference of all my chunk that I can interact with. So it doesn't update all those three while I'm just in this one. So this is the first part. Then what I do next is, as you saw, I have a sphere in front of me that I can like increase or decrease and place stuff, yeah, and remove. So how I increasing decreasing the sphere size is here in this part where I just take the sphere and increase the world scale, and then this world scale I'm using it to draw and remove matter. So everything is happening in these two functions. Those two functions take the information of my sphere, the diameter and stuff, and update everything in the blueprint. So it's happening in two parts. First part is updating the render buffer, so taking all the information. I need to render the mesh, and then another one which draw and remove the buffer that I've just made. So because it's already been drawn and we don't need it anymore, so it's removing it from the memory. So I'm gonna go into this one. So as you can see here, there's another timed loop. So every 0.1 seconds, while I'm holding the mouse. So here is the mouse when I hold them. So I put a variable here, a boolean, when it's checked or pressed. So I know constantly when it's pressed or not pressed. And then in this one, I just take the information and do the right calculation, the right thing when I have my left button clicked or right one. So if the left button is pressed, so it means that I should create matter in the grid. So I call this function, which is update grid from sphere, and this one will take my sphere position, so the blue sphere that is here in my first person character, and then it will take its size. So the size is get component bounds. So there we go. And then I set a new state of true. So every point in my grid will be set to true, and in Marching Cube, when a point is set to true, the Marching Cube algorithm will try to encapsulate the points with geometry. So this is how everything works. So then, once my grid point is fully operational, uh, I I take this grid info and I gather every information. So I calculate the vertex position, the normal position, and everything, the little mesh position and their orientation. uh, gather all those information into a buffer, uh, because it's made in async. So the async is made to not interfere with the main game thread, so there is no shuttle lags or stuff like that. So I'm just making those buffer, stacking them in a queue, and then setting back to 0 so I can uh, stack buffer in my queue over and over again. Then I need to have a way to uh, render actually all those information and then remove this queue, this buffer from the queue. So in the event graph, it's this function. So what I'm just taking here is I'm taking the grid information. So it's the object that manage everything in the C++, but you don't need to know that. So I'm taking all the information in the queue. So I have the vertex queue, the triangle queue, the normal queue, little mesh queue, and the little mesh orientation. So I take all those buffer and I do the render. So if they are all equal in size, that means it's a complete buffer. So I do the render, and this function is derived from deformation mesh base. So this blueprint, which is derived from this C++ class, and if I double press in this function here, here's the function. So this function takes vertex, triangle, normal, little mesh, and position a little mesh normals. So it's rendering everything in those components. So the procedural mesh component for the surface mesh and the little instance for the little rocks, the surface rocks. And then once I've done all the rendering, I just remove those buffer. So at the end, when I'm not touching the mouse, I have 0 buffer queued, and then everything has been rendered and it's up to date. So if I can resume the workflow, is I'm creating buffer here, that I'm stacking them, and here I just render the buffer and decrease. So with this technique, I'm able to draw everything with a smooth FPS, and if the render time is slower, then it will just impact the time the whole structure will update, but not the actual FPS of the game. So it's a way to optimize and not get too much FPS drop. So because this technique is a bit expensive. So now what I'm gonna talk to you about is how you can record the grid. So for me it's still in the first person character. So when I press R, I take all the active blueprints, so the one which I'm in, then I capture the grid configuration in this function. So it's a function in C++ that check if I have a data set. So for this to work, you must have in your blueprints a data set field here. So you must have one in here, in here, as I talked to you earlier. Because if you don't have a data set and in the data set a chunk, a slot here named, it will not save. So this is what this method is for. So you have to, yeah, it's reference to blueprint mesh standalone, so the object. And then after that I refresh everything. I draw the actual mesh, which is on screen. And then the last thing I want to talk about is the clear. So when I press C, it just take every active mesh, it loops through them, and then I have a fill grid here. This function just take everything on the grid and then activate or deactivate the states. So yeah, and then after that you do the same thing and you gather final mesh info and you render them. And just a final thing I forgot to tell you about is on begin play, uh, to gather all the blueprint I need to make the check, I just on start get all the action class, all the actor class, and then I put it in a big level deformation mesh array, and then I iterate to them to see if they are activated or deactivated. So I think it's everything for me I had to share with you. Feel free if you have any question, feel free to join my Discord that I have linked in the description of this tool. So if you have any question or problem, I will be there to solve them because it's a pretty tough one, a pretty big tool. So I'm sure you guys will have some questions. So thank you for everything. I hope my tool will suit your needs, and see you in the next one. Bye.